Hello everyone, and welcome to this short presentation where we will show you how you can integrate graph embeddings into your ML system. By now, the benefits of machine learning are very clear. Whether you're using static data, batch data, or real-time data, people are starting to see how they can leverage this in their specific environments. But at the same time, we see that the ecosystem integration complexity has in fact exploded. It's not just the ecosystem. The engineering complexity as well has risen to a very, very high level. All of these different components need to be integrated into your ML system. This is where Hopsworks proposes a different type of architecture centered around a feature store. We will organize all of your feature pipelines, your training pipelines, and your inference pipelines around the same piece of software infrastructure. We will leverage your Neo4j data and put it into an architecture where you combine the online and the offline data together into one integrated platform for all of your different pipelines. And while we do that, we will also make sure that you will have one unified, well-governed platform for all of your AI requirements. And in order to provide you with the most stringent governance requirements, we will offer you the flexibility to deploy wherever you need it to be deployed, both as a serverless endpoint or in your own cloud environment or in your own on-prem data center. So let's now turn our attention to how we integrate the Hopsworks feature store with Neo4j. On the one hand, we want to bring the power of Neo4j and graph analytics to the world of Hopsworks, right, to the feature store. And on the other hand, we want to also offer Neo4j the possibility to actually deploy and operationalize their graph features in a true feature store-based MLOps platform. Let's start by showing you a little bit around the Hopsworks environment, right? Here we have the Hopsworks environment where we can have feature groups, feature views, our compute environment, our jobs, our airflow, our model registry, our deployments, and all of that in one and the same platform. Right now, this environment is completely empty, but what we'll do, of course, is we will go and connect this environment to Neo4j. We have a Neo4j Aura environment here. Aura, where we are going to load, engineer, and connect some of the Neo4j based features and put them into the Hopsworks feature store. We will do that by using a notebook, right? A notebook where we will run several cells one after the other to create the data in Neo4j, right? This is what we're doing here now. We're first creating the indexes, and now we're going to start and load the data into Neo4j, right? The first one is really easy. We only load like a couple of thousand nodes here, but very quickly we will also load the relationships, right? So now first we have the nodes. The nodes are parties, right, that are going to interact with one another. So now we have to load those transactions between those parties from a CSV file and do that into the Neo4j Aura environment. Right, this is super easy. You know, it's just a very simple couple of cells that we have to load. And as I refresh this here, you will now see that I have about 7,347 parties and 438K transactions between those different parties. Now, what we're going to do in the rest of this feature engineering capability is we're going to load some of the other data, right, into our environment here. But then what we're going to do is we're going to calculate something we call node embeddings. Right? Node embeddings is a representation of the structure of the graph in a vector format, right? So we're going from a higher dimensional graph into a lower dimensional vector, right? So that's what we're going to be doing here. When we do that, we write a new property into the party nodes in Neo4j. You will see that coming up here, right? So the parties now all of a sudden have a node2vec property, which represents how that particular node is connected in the rest of the graph. Then we go and do some more feature engineering outside of Neo4j, right? We have a number of transactions that we want to also create feature groups for, parties that we want to create feature groups for, and all of these things are now being added in our notebook. Hopsworks will allow us to validate this data, right? It will validate this data using Great Expectations, right? Great Expectations is a validation suite that we can use to make sure that the data is actually complying to the rules that we needed to comply with. And when we have done that, when we have checked for all of that compliance, we can actually go and register the feature groups in Hopsworks, right? This takes a little bit of time, right? This upload of the data and the materialization into the online and offline feature store. It takes a little bit of time, and we will make that happen over here now, right? So this is something that is now going on, right? We will get all of the embeddings, and then we will manipulate those. And as you will see now, there are no feature groups here yet, but I'm going to start to upload those into the Hopsworks environment right now, right? Uploading the data frame, right? So there's a little bit of time that goes by here, and we will just skip over this a little bit more quickly. And then the other ones are the transactions, the monthly aggregates for the transactions that are going to get added to the feature store, together with also the party feature group that are also going to get added to the Hopsworks feature store. Once this is done, we can check the Hopsworks environment and make sure that everything has been added the way we want it to be added. Right, so refreshing this page here, look at the graph embeddings, transactions, you know, all of this is now there, right? But you will also see that some of the materializations will take a little bit more time, right? So this is actually something that you will see in the jobs of the Hopsworks environment. You will see that it is actually still running, right? So you have to have a little bit of patience here before all of the feature engineering pipeline has been completed. So here we go. Now you see that the entire materialization has been completed. We have our feature groups, and now we can proceed to the next step and start our training pipeline of our machine learning system. So here we go. We now start this second notebook and we do our imports. Once we do that, we connect to the Hopsworks feature store and start selecting the features that we need for the training, right? So this is what we're doing here. We're jumping from cell to cell. We're selecting the features for the training data. And once we do that, we can now show what we have selected, so the features, using arrow flight. It's pulling those from Hopsworks. Next thing we do is we do some transformation functions so that we can now start creating the feature view. And the feature view is the part that we will need in order to create our training data set. Right? We currently don't have the training data set yet, but we have created the feature view, which is a logical representation of the feature groups and combining them together so that we can actually start creating the training data. Right? This is what we're going to do right now. We're going to jump back to our training data set creation cell here, right? We're going to get the training data, and once we have that, we're going to quickly show it, right? The first row at least, right? We can see that right here. We'll do that for the different parts of the training data so that we can now start building the model. Right, so now here we go. We're going to start building the model, right? This is a multi-step process, of course, where we kind of have to filter the things that we need or don't need. And here we go. Now we have a architecture that allows us to train the model. The architecture, you see it over here in this little visualization. The steps are quite simple. We have to compile the model here. This is something that is going to be done very, very quickly. And now we are ready to register this model in the Hopsworks model registry. There's a couple more steps that we need to do here. We're going to create the model schema and then upload that into the Hopsworks environment, register the model. It can be prepared so that it can be deployed on the Hopsworks infrastructure. This is a very, very simple process. It takes a little bit of time. And then we immediately see it in the Hopsworks environment, right? We see the AML model has been deployed here in the model registry. And I can now go ahead and actually make this available for my prediction services inside the Hopsworks environment. Right, so it's now doing that. It's getting the model from the model registry, and it's going to then make this available and run it inside the Hopsworks environment so that people can call it and make predictions using this particular model. Right, so this is what we'll see here, right, in the deployments, right? It's creating the model right now, and it will start the deployment to be available on top of Hopsworks. Now, once we have that and we have the model actually deployed and it's running, that means that we can actually turn our attention to the third notebook that we have here, which is our online inferencing notebook. What we're going to do here is we're going to connect to Hopsworks, get the model from the model registry, make sure that it's running, right, that it's actually been deployed, and then we can actually start predicting using our deployment. Right, so this is what we're doing here. We're sending some data to the prediction service, and once that prediction service has applied the model and come back with some data, we can actually show the prediction that it is going to make. In this particular case, this is going to be an anomaly score, right? So it's going to give us back a score. We can do this one by one, or we can actually do this in batch and send it a bunch of particular prediction questions and see what it comes back with. This is what we've done here now, and this is how you can actually make sure that your Neo4j graph embeddings actually make it into production as a deployed, fully deployed machine learning system. This is what we've shown you in this little demonstration. I hope this was useful, and I wish you a wonderful rest of your day.